Hello, everybody. This is lesson 9 in Math 100. So this is the lesson about borrowing money. I have been saying this many times now, but when you borrow, when you save money, the power of compounding interest works for you. Okay, but when you borrow money, especially for a long period of time, such as in student loans and in mortgages, the power of compound interest works against you. Okay, so today we'll get to see what it's really like when you borrow money, especially for a long time. So pay close attention. It's going to maybe save you hundreds of thousands of dollars in your lifetime. All right, so let's get to it. Okay, so today's lesson title for lesson number 9 is loans. Oops, different color here. Loans. Okay, and in order to borrow money for a long time, especially for things like houses, these long-term loans are sometimes called mortgages. All right, and so this is the idea. Basically, it's about borrowing. Okay. All right, and so you could also call it debt because that's what you will get when you borrow or take out a loan. All right, so the main question is this: how much would I have to pay every month in a 30-year mortgage if you have to borrow $500,000? It seems like a lot of money, but again, in the typical suburb, a house may cost well beyond $500,000 these days. And if you can get a interest rate of 3.6% monthly, this one fluctuates depending on the economy. Sometimes it's higher, sometimes it's lower. In the past, it has been way higher than this. So, this is the kind of thing we'll be asking. Can we afford that car or the house? How can we save extra money? Is there a way to, save some money in the long term? Okay, so this is a very practical question, and it's a very practical topic. All right. So recall that money has what? Time value, right? We have been calling money time sensitive. The amount of money grows. So if you remember, if you have this timeline, here's now and here's later, and because of compound interest, if you deposit $100 today, later it's going to be more than $100, right? That's how much it's worth. Now, of course, it's a little more complicated in the real life because if the inflation rate exceeds the interest rate, then even though you have more than $100, maybe it's not worth that much at that time, right? So it is a little more complicated, but we will not worry about the inflation rates and other things at this point. Okay, so when money is moved forward, okay, so you have, remember this, I'm going to write this in red. You have learned, okay, how this works. So you multiply this with a compound interest, and this is a formula I gave you. K is the number of compounding periods per year. So K is 12, for instance, when the compounding occurs monthly. The number of years is N. That's how many years you are going to invest. And R is the rate. Okay, so you remember this formula. This is the, I think the second formula you learned, I think in lesson 7, right? So when moving money backwards, what happens? What's the difference? Well, actually, mathematically speaking, the only difference is this little negative sign here, okay? So that's the only difference. Maybe I should just underline this, okay? And because when you move the money, okay, you're compounding it. So there is a not linear, but exponential growth. Well, the exponential decay basically kind of goes backwards, okay? So for instance, if you want to have $100 in the future, let's say 5 years from now, $100. If you bring it back, it's going to be less than $100 because this less than $100, say $90, will grow and add interest and become $100, right? So when you go backwards, you actually just put the negative sign. And so mathematically speaking, this is a pretty simple, difference. Okay, so in order to illustrate how this works, let me just give you a background to the formula I'm about to give you. The formula will be down here, okay? So this is just a sort of a setup to help you understand where the formula is coming from, okay? So also I should have there's a number line here, okay? Let's say you have, suppose on January 1st, right here, January 1st, okay? You agree to make 12 payments of $100 at the end of each month. So suppose that, you know, you need some money. This is a New Year's and you just need some extra money for the coming year. And you say, hey, look, maybe you talk to your friend or a bank or something and say, I would like to borrow some money, and but I'll pay you back. The way I will pay you back is this. I am going to pay you $100 every month at the end of each month. Okay, so what does it mean? At the end of January, so January 31st, you are going to pay back to your lender $100, okay? And at the end of February, February 28th, you're going to pay back another $100 and so on. And you make 12 monthly payments, right? The last one being on the last day of the year, which is December 31st. Okay, so you have 12 $100 payments. The question is, how much can you borrow today with the interest rate of 12% compounded monthly? All right, so you can see here that R is 0.12, that's 12%. And by the way, when you borrow money, the rate is usually significantly more than when you save money. Okay, so that's just the way it happens. And then K is 12 because it's monthly, right? N is 1 because you're just talking about 1 year, right? So the idea is, by the way, the wrong answer is this. The wrong answer is $1,200. You will not be able to borrow $1,200 today, even though you promised to pay $100 12 times in the future. Why not? Okay, well, here's the reason. $100 in the future, even a month later, is not worth $100. It's probably like $99 or $98, okay, because of the compound interest of 12% monthly. And then the $100 2 months from today is going to worth even less than that when you bring the $100 back, okay? Just like, you know, when you went forward, the money grew. When you go backward, the money shrinks or decays. And this last payment, and of course you have, you know, 9 payments in between them. The last payment is going to be significantly less than $100 because you promised to pay this $100, but not until December 31st. Okay, so now you get to add all the amounts. Okay, so this is called the present value of all future payments. You get that? You are making payments in the future, equal amount, but when you bring them back to the present, they are all valued at or worth different amounts of money. All of them less than $100 because all the $100 of payments are in the future. Okay, does this make sense? Okay, it's very important for you to understand this. Okay, all right, so it's going to be less than 1,200 you can borrow today. All right, so let's go ahead and calculate, you know, some of the key things we always calculate here. If it's 12% monthly, basically it's telling you that you are borrowing at 1% every month, right? And of course, n times k is 12. And so we can do this manually for each one. What does it mean? Okay, so today, if you borrow $100, if you are going to pay $100, 30 days from today, 1 month before that, you have $100. It's earning the interest of 1% for that month. Okay, so this is, you know, so this is 1 plus 0.12 divided by 1,2, and that's going to be 1.01. Right? And that is the multiplicative factor when you are increasing, you know, the amount or any number by 1% every month, right? So 1.01 is the factor that you are multiplying this principle by, except in order to go, if you're moving forward by a month, you go like this, but if it's backward, you go this way, okay? So this happens to be 99.01, okay? And I'll show you, you know, how this thing works on the calculator. But and then the how about the one the $100 payment you're going to make at the end of February? That would be $100. You bring it back by 2 months, okay? So that would be -2, and that's 98.03. All right, and then so on, and just keeps going. How about the last one, December 31st? This amount moved backwards with 1% interest every month, otherwise known as 12% compounded monthly. You have to bring it back by 12 compounding periods, and this is only worth 88 $1,274. Okay, did you get this? Right. So again, this $100 you're going to pay at the end of January is now worth 99.01. The second payment you promised to give back at the end of February is now worth only $98.03. And the one that you're going to be paying back 12 or a year from now, basically, this amount of $100 is only worth 88.74 now. These are the present values of all these payments. All the present values are different. Now we end up adding all of these. All right. Now, this is complicated, right? Just like, in the annuity case, it was hard to calculate this. So then what do? We use, again, the formula from a geometric series. And the mathematical concept, it's a advanced mathematical concept called geometric series, actually gives us a nice formula. It is sort of complicated. And again, you do not need to memorize this formula, but here's the formula to find the present value, P, present value. So this is P naught, okay? And it's zero because zero basically means now. Remember, if it's P5, that was like an amount 5 years from today. P naught or P0 represents the present value. And this can be calculated as follows. Now, in this case, by the way, the amount of monthly payments was $100, right? That's what we call D. So it's D times, and this will look very similar to what you had before, okay? But the formula goes like this. Because we are moving the money backwards, it will look similar, but a little different, okay? Which is really confusing because it looks similar to the annuity formula, but slightly different. You could be easily confused. But here's the point, 1 plus R over K. Now, this is something quite familiar. In this case, it was 1.01, right? And in the previous case, you had N times Kth power. This time it's, remember what, because it's going backwards, negative N times Kth power, right? And then we subtracted 1 from this before, but now we subtract 1 from this number. And the reason this happens is because this number that we calculated, 1 plus R divided by K, raised to the negative N times Kth power. This actually happens to be a number smaller than 1. You subtract 1, you subtract this number from 1, and then you divide it by R divided by K. Same thing as before. This is the compounding rate. This is the rate per period, if you remember. Okay, so this is a big fraction. Okay, and I know this is a complicated formula, but really, this is the formula that every financial institution, every bank, every lender uses in order to calculate your present value. Or given the present value, they will be able to figure out your monthly payment, okay? This happens every time you pay your credit card bill every month, or when you buy a car and finance it, or when you buy a house and take out a mortgage. It's the same, it's a very basic and same principle, all right? And so this is the formula, okay? Let's go ahead and apply this. And I'll have several examples, and then there will be problems where you are to find the monthly payment, which is more practical. That's on the second page. Okay, as before, I'm going to tell you this right now. You do not have to memorize this. Okay, and most of the people, in fact, probably all the people in the financial world will not have this memorized. In fact, very few people even know that such a formula exists, and they just punch this into the computer and have the algorithm calculate, these things like the present value and the amount of monthly payments. So do not memorize, okay? And in fact, I am not going to have you, so you will need this. You will need this for your homework, okay? But I will not ask you to use this on your exam because I don't want to provide this long formula on the exam. The thing is, you will need to be able to calculate this given this formula in order to, compare differences in loans and so on. And that much, I think, is an important skill. But for you to have to memorize this or to apply this on your exam, I don't think that's an important thing. Okay, so let's do an example first, and we'll find out how useful this is. Number one, you can only afford $200 a month, monthly payment of $200 for the next 5 years to buy a car. Okay, so let's say you have a car, you want to buy a car, you want to buy a reliable car because you are sick and tired of having an old car that breaks down all the time or with a bad fuel efficiency. But you know, you can't really afford a car right now, but you can make $200 a payment of $200 every month for the next 5 years. Okay, you are willing to do that. You go to a dealership and they'll say you have 6%. This is a pretty high interest rate, but you know, 6% monthly. How much can you borrow today? Okay, can you buy that dream car that costs $12,000 or $20,000 or whatever? Okay. So what is that? Okay, let's go ahead and calculate this. In this case, let's go ahead and write down all the important numbers. $200 a month, that's D, right? Okay, and the next 5 years, N is equal to 5. 6%, 0.06 is your R, all right? And remember, from these, you should calculate R divided by, or K. K is almost always 12 because almost all borrowing happens on a monthly basis. You make your monthly payments, right? So R over K, this will be 0.06 divided by 12. Not surprisingly, this is 0.005. In other words, 0.5%, half of a percent every month. And then N times K. Okay, remember that would be the negative of this exponent. N times K is 5 times 12, that's 60. And again, this should make sense because, I mean, don't, you know, just calculate these numbers blindly. What does this 60 mean? You should ask yourself. Well, that's 60, no, that's a number of payments. If you pay every month for 5 years, you are making 60 payments for this car. All right, and this will allow you to calculate what? According to this formula, the present value, that's how much money you can borrow today. All right, so you have $200, and then you have this big set of fraction, right? It's 1 minus 1 plus, and should I just write, you know, because I know this number here, it's a simple number, 0.005. So it's 1.005 raised to the negative 60th power. You see that? Okay. Don't forget the negative sign here, negative 60th power. And this number will always be less than 1. Okay, if you get something more than 1, something's wrong and you should do it over again. The fraction, the denominator is R over K, which is 0.005. Since it's a simple, you know, fraction, it doesn't repeat forever, you can write it down like this. And that's the formula you're going to use, all right? The answer, I'm going to write this down and I will show you how to get this in just a moment. The answer is going to be $10,345.11. Okay, so keep this in mind and I will show you how this is to be done on your scientific calculator. Okay, so this is a type of scientific calculator. Your calculator may have different options and different keys. So you should learn how to use your calculator, but this is a sort of a typical one. In fact, what I'm showing you is the scientific calculator that comes with the Microsoft operating system, the Windows. I think it's Windows 10. But anyway, so if you do, you know, just follow what we just wrote, 1.005, right? That's 1 plus R over K. And so then you raise it to the power of, remember this, raise it to the power of, this is the key. And then you raise it to the 60th power, except it's negative 60th. So how do you write that? Okay, some of your calculator will allow you to put negative 60 in that order. Unfortunately, in this calculator, you have to enter 60 and then plus or minus. Watch what happens here. I put 6, 0, and then see this sign here, or see this key, plus or minus. This will make that 60 into a negative. Notice here on the upper right top corner, the top right corner, I am showing 1.005 raised to the negative 60th, okay? And I'm going to enter and put the equal sign right here. And so this is that number, 1.005 raised to the negative 60th. Okay, now I'm supposed to subtract this from 1. You can go ahead and write down like 5, 10, 6, 10 digits of this number and do 1 minus that. What I will choose to do is to just subtract 1 from this, okay? So watch what happens. It's minus 1. And that is the opposite of what I have in the top. Okay, so I really don't like to have that negative sign because, instead of doing 1 minus that number, I did that number minus 1. So I'm just going to get rid of that negative sign by doing the plus minus again. So I enter the plus minus. Okay, so 0.2586, that's the numerator. That's the top of that fraction. Okay, now I'm going to divide this by 0.005. Okay, again, pay attention to what I'm calculating on the top, on the top right corner. Now this, and I'm going to enter or press the equal sign. This is 51 point something. This is the entire fraction. All I have to do now is to multiply this by 1200 and you will get the answer. This is how much you can borrow today if you promise to pay $200 every month for 5 years at 6% monthly. The answer is $10,345.11. Okay. All right, so that's the math part. Okay, now let's come back to the reality. All this is done if you are sitting at the let's say you are sitting at a car dealership, okay, and you're ready to buy a car. And actually, they may not even tell you the interest rate until you keep asking, okay, because they won't say, hey, how much can you afford? Let me figure out, and then they adjust the price, because that's how that business works, right? I mean, seriously, I have been to car dealerships with my scientific calculator, and I tell them, hey, look, I teach math for a living and so on. And then they give me a what they call a great deal. And I say, well, look, that's a terrible deal because look at the interest rate you're charging. And then they will say, let me go back and figure this again. So don't be deceived. Don't be fooled by their smooth talk. I'm not saying car dealers are terrible, but you just want to be aware of the kind of calculations that take place. And by the way, most of these people still will not be able to do this, okay, because they just punch numbers into a computer. So what we have found is even if you make this strong commitment of making $200 payments every month for the next 5 years, that's 60 payments of $200, you can only afford a car or afford a loan that will give you $10,345.11 today, okay? You will not be able to buy or borrow $20,000 to buy that fancy car, okay? By the way, the amount of money that you are paying or the total amount of payment, this is called the total payment, by the way. The total payment, sometimes people call it total payments because there are multiple payments. The total payments is $200 times $12 a month. Sorry, no, 12 months a year for 5 years. Okay, this is 60 payments of $200. That totals $12,000. Okay, so what's the difference? The difference between the amount of money you're paying, $12,000, and the money that they are willing to let you borrow, which is $10,345.11. The difference is $1,654.89. Guess what? This is the total interest amount you are paying. Okay, in other words, because they are doing you a favor by letting you borrow money, okay, they are charging you this service fee. Service fee is another word of saying, thank you for doing business with us. We really appreciate it because that's how we make our money, okay? So you're contributing to their wealth, thanks to their service, because you are borrowing money, right? And in the 5-year period, you are going to be paying $1,600, basically $1,654 extra because you are borrowing money. Okay? Of course, it's better to have cash. Of course, you can't always afford it. But the difference between the amount of money you can borrow today and the amount you will end up paying for the entire period is called the total interest. This is an important number. I'm sure I will be asking you this in your homework and on your exams, okay? Even though you don't have to memorize this formula. All right, so let's go to the back and here's the formula. And maybe you can, if you are fairly good at algebra, try to solve this equation, okay? Try to solve this equation for D. The reason you want to do that is because many times you already know how much you want to borrow. What you're interested in is, hey, how much do I have to pay, right, every month? So in order to make this into a more practical formula, let's try to solve this for D, okay? And then find out how you calculate D as a formula. And when you think you can do that, and when you think you have done this, you can come back and watch the second part of this recording.